All right, in this section, we're going to look at the fundamental principle of counting. I think you're going to like this concept when we kind of break it down with the examples here. For our first example, we're going to use an ice cream shop. Doesn't that sound yummy? And the ice cream shop called Dairy Island has these sizes, flavors, cones, and toppings. And so the first question is, well, how many different cones can a person order at Dairy Island? And we could spend a lot of time writing all of these out because you could get a small vanilla cake cone with a shell. You could get a small vanilla cake cone with candies, small vanilla cake cone with sprinkles. You get the idea. But the simplest way to find out all the different combinations is to look at how many sizes can you get. There's 4. How many flavors can you get? That's 5. How many cones? You can get 3. And how many toppings? You can get 4. And if you'll multiply these all together, you get the number of combinations. So let's do 4 times 5 is 20, times 3 is 60, times 4 gives you 240. Okay, now if we ask ourselves how many different small cones can a person get, well, see, now we've eliminated the options in the size category because we're only going to do one size. So now we have 5 flavors of small cones, 3 different kinds of small cones, and still 4 toppings. But you see how we eliminated the size option because we've already chosen. We're going to have a small cone. So let's multiply these. 5 times 3 is 15, times 4 gives me 60. Okay. A last question for Dairy Island. How many different cones can be ordered without toppings? So now we're eliminating the toppings option, but we still have 4 different sizes to choose from. We have 5 different flavors to choose from, and we have 3 different types of cone. We're just not choosing any toppings anymore. So now we multiply these. 4 times 5 gives me 20, times 3 gives me 60. All right, let's dig a little deeper. All right, in this example, we're going to have cards of 3, 4, and 5. And we're looking at an example where you select 2 cards at random from the 3, 4, 5 cards. And then we want to list all the possible outcomes you can get if you put the first card back before picking the second one. So let's say for our first card, you could have 3 options, right? You could pick the 3, you could pick the 4, or you could pick the 5. Okay? And then whatever you pick, let's say you pick the 3, you're going to put it back before you pick the second one. So the next time you pick a card, you have 3 options still. So you could have 9 options here. See, you could have the 3 and then a 3 option. You could have the 3 and 4 option. You could have the 3 and 5 option. You could also have pick the 4 first, and you could get a 3, the 4, and then the 4, and the 4, and then the 5. So you can get 2 4s because you put the 4 back. And the same would be true for the 5. Okay, but now look at my next question. We're going to still select 2 cards, but you don't put the first one back. Okay? So let's say you pick the 3 first, then you could pick the 4 or the 5. You couldn't pick the 3 again because you didn't put it back in there, right? Now, if you have the 4 first, then you could pick the 3 or the 5. And the 5, you could pick the 3 or the 4. See, the way this one plays out is that the first card you pick, you have 3 cards to choose from. But the second card you pick, let's say you've already chosen one, you only have 2 cards, so you only get 6 options. So very important when you're dealing with problems like this is you need to know if you put the first card back or not, because it's going to make a difference in your answer. All right, let's look at a good word problem here. You have 3 students who are renting a 3-bedroom house near campus. One of the bedrooms is very desirable because it has its own bath. Sounds good to me. One has a balcony and one is undesirable because it's very small. And how many different ways can the housemates choose the bedrooms? So remember, there are 3 bedrooms to choose from. I just use blanks to kind of hold them out there. And let's say for the first bedroom that's very desirable, how many students could choose this one? Well, 3 of them could. Okay. Then this person, let's say they've already chosen theirs. The next person, the next bedroom, there's only 2 people to choose from. And of course, the third bedroom's only going to have 1 person left because obviously 2 people, so 1 person cannot have 2 different rooms. So there are 6 different options there. Again, this is a without replacement option. Now, the last part of this lesson looks at something called a factorial. Now, a factorial is what we are using this little exclamation point with. So when you see 6 factorial, here's what that means. That means to start at 6 and multiply by every number, by every whole number less than 6 until you get to 1. Okay, so if you multiply those, 6 times 5 is 30, times 4, 120, times 3, 360, times 2, 720, times 1, 720. All right, now, where that comes to be interesting is when we have factorials being divided. So let's take a look at what this means. 8 factorial divided by 5 factorial. Well, 8 factorial, we know that means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, and then on the bottom, when we do 5 factorial, I'm just going to line it up for a reason. I'm hoping you're going to see why I'm doing that. 5 factorial means 5 times 4 times 3 times 2 times 1. But what happens? Well, the 5 divided by 5 gives me 1. The 4 divided by 5 gives me 1. The 3 divided by 3 gives me 1. The 2 divided by 2 gives me 1. The 1 divided by 1 gives me 1. And so I'm left with here 8 times 7 times 6. So 8 times 7 here is 56. And 56 times 6 is 336. Sorry, I had to do that one in my head. But you can see how they cancel out. I think that's the important piece for us not to miss when we're looking at simplifying these. All right, one more here. Let's do 8 factorial divided by 3 factorial times 5 factorial. So 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, and then we have 3 factorial, which is 3 times 2 times 1. And then we have 5 factorial, which is 5 times 4 times 3 times 2 times 1. Okay, so let's cancel, just like we did on the previous example. 5 divided by 5 is 1. 4 divided by 4 is 1. 3 divided by 3 is 1. 2 divided by 2 is 1. 1 divided by 1 is 1. And then also, I want you to see that 3 times 2, well, let's just write it first. Let's not get ahead of ourselves. All right. So 3 times 2 is 6. So really I could do 3 times 2 cancels with the 6. And I'm left with the 8 times 7 divided by 1. Well, 8 times 7 is 56. And 56 divided by 1 is 56. So that's how we can simplify that. Notice I didn't multiply really until the very last step, right? I just write out the multiplication and look for those cancelings. So I hope this helps you with the fundamental counting principle. Thanks. See you soon. Bye-bye.